Welcome to GibbsCAM Tech Tips. My name is Michael Carter, and today's topic will be importing machines for simulation. I think everyone can recognize the importance of getting an accurate machine simulation in their CAM product, especially for more complicated machines such as 5-axis or Swiss. But because of GibbsCAM's universal kinematic machine, this is actually one of our biggest strengths. So when you receive your machine simulation from either GibbsCAM or your reseller, it should come in a zip folder or some other kind of compressed package file. However, there are a couple easy steps you need to perform in order to get your machine simulation up and running in GibbsCAM, but it's actually very easy, and I'll show you how in just a couple minutes here. So this is an older version of GibbsCAM here that I have my machine in, and I want to get it running in my new version here. So I'm going to stop this, and we're going to switch over to my new version here. And this is just a splash screen. I haven't loaded in a part or anything like that. I'm going to open up my File Explorer here and just navigate to wherever you saved your package file, your zip file that you got from your reseller. And I'm going to be loading in a Haas UMC 1000 in this case, the same machine you just saw prior. And all I have to do is click and drag this and drop it right onto the GibbsCAM splash screen. And a post-package extractor comes up here. It's called the post-package extractor because your machine typically comes from the post department and it works with your post to create that simulation. So all of these are actually the individual components of the machine. It's not an assembly. This allows us to, move an individual component without moving other pieces. So these are all the different pieces of our machine. You can see there's quite a lot to it. And you can just go ahead and hit OK. But in this circumstance, I'm going to show you Open Target Location just to show you what it did here. So this is my GibbsCAM install directory. And if I go into my machine sim folder here, we can see that it has taken the Haas UMC 1000 folder and put it in here. And here's all the components that I was just talking about. In addition, it took some of the other things like the MDD, the machine definition document, and it's also sorted that into your install directory. So it did all that automatically. This is definitely the recommended procedure for how to do this here. So I'm going to close that out and hit OK here. So now we're ready to open apart and see our new machine. I have here a 5-axis impeller that I've previously programmed. And if I open my tools in CAM, you can see that I do indeed have a couple operations here. So the first step to doing this is we want to go to our document control box here. And this is a list of all my MDDs that I have. And you can see that Haas UMC 1000 is in fact in here. So I'm going to select that as the machine that I'm using. And we have to make sure to match this to our simulation here. So I'll show you how to do that. I want to use the machine simulation, not OpSim, because machine sim is the one where we can actually render that kind of stuff. And it won't be loaded in by default. What you have to do is go to load machine here, and these are the 4 machines that I have, and I'm going to hit load machine, and it loads it in. It's pretty simple. Might have to rotate, get the right angle to see the front here, but that's our machine. You can see it only took, maybe a minute to actually get this in and working and running. And there's one more thing I like to do before we actually simulate this. And one thing is turn on program error checking, and this will check your program for errors like the name denotes. And then the other thing is collision checking, and you want to make sure that that's on, and that's going to detect throughout the simulation if anything collides with anything else. And it doesn't have to be the stock, it can be fixturing, it could be components of the machine, any solid model that you see here. If 2 things collide, it will let you know. Okay? And then the last thing we have to do is right click on the bar here and go down to settings, and you can turn these on. I'd like to turn all 4 on, but basically what you're telling this to do is, hey, once I've found a collision, what do you want me to do about it? So I want it to beep, I want the stock to flash, I want to display, and I want you to stop. Okay? So now that that's done, we're ready to hit play and see what happens. And you can see pretty immediately it did indeed find a crash, and it tells you which components are colliding. So we have the C-axis hitting the spindle in op1, and then it gives you the XYZ coordinates of where that collision is happening. And you can see it also turns the two components yellow, and there's a nice little red dot there showing you where these collided. So as you can see, it only took about 2 minutes to actually get this set up and working with all the settings that I like and that kind of thing. So it's pretty easy. Ensuring that you have an accurate machine simulation is key to many kinds of advanced machining, as well as protecting the investments that you've made in your machines. In GibbsCAM, it's easy to set up and use your machine using this method. If you haven't got one already and would like to get a virtual machine running, please reach out to your local GibbsCAM reseller. Thank you.